Good morning, ladies and gentlemen. This is Mrs. Quinn's geometry. This is section 5.3 proofs. First of all, how can we justify that segments are congruent? Hopefully we remember the segment congruence theorem. If your segments are equal, then they are congruent. How can we justify that angles are congruent? That's the angle congruence theorem. We need to keep all these theorems in the back of our head. And so I strongly suggest you make sure you have that theorem, definition, postulate page handy. So if we're making conclusions with justifications, if I'm given that LX is a perpendicular bisector of AC at point B, let's see what I know. If this is my line segment AC, and I have the line segment LX at point B, and it's the perpendicular bisector of AC, I would know that this is a right angle and this is a right angle, and I would know that these two side lengths are congruent. Agreed? So a lot of times it's helpful to draw a picture of what you're given. Next, if I'm given the circle at C and I'm told this, what can I conclude? Automatically I see all these radii, and all these radii must be congruent. Agreed? How about if I'm given a transversal? If I know that these lines are parallel, cut by another line, I know that all my corresponding entries are congruent. So angle 1 is congruent to angle 5, angle 4 will be congruent to angle 7, 3 is congruent to 6, and 2 is congruent to 8. Then I also know, due to the vertical angle theorem, that 6 is congruent to 8, 3 is congruent to 2, 1 is to 4, and 5 is to 7. Notice that if we know one angle for transversal, we can find all the other 7. All right, so if I'm given M as the midpoint of AB and I want to make this conclusion, I suggest that we go ahead and draw it first. Here's my segment AB, and I have midpoint M. Then I can conclude automatically this. And think about why. Why do I automatically know that this segment is equal to this half of the segment? Have you thought of the reason yet? If not, keep looking. It's either a theorem or a definition. So in our proof, we're going to start with M is the midpoint of AB. And we know that because it is given. I can jump to my conclusion that AM is congruent to MB. Did you find it yet? Hopefully you'll agree with me. It's because of the definition of midpoint. By definition, it tells me if it is the midpoint, then it is equidistant from its endpoints. So I would put definition of midpoint. Now make sure that these one-step proofs are getting really comfortable for you, because in the very next section, we're going to take it up a notch. We're going to have multiple steps. All right, we want to look at this transversal right here, and we're given that L is parallel to M, and we want to prove that angle 1 is congruent to angle 2. Now, I'm going to go ahead and start writing, and you look in your book and see if you can find what theorem or definition gives us that. Oops. Angle 1 and angle 2 are what kind of angles? Would you agree with me that they are corresponding angles? Hopefully. And by what definition or theorem? It is a theorem, isn't it? By what theorem do we know that corresponding angles in transversal are congruent? Make sure I get the name right. This is the corresponding angles postulate. Suppose two coplanar lines are cut by transversal. If two corresponding angles have the same measure, then the lines are parallel. Conversely, if the lines are parallel, then we know the angles are congruent. So my only justification I can give right here is the corresponding angles postulate. And we can use shorthand notation. Corresponding angles postulate. Now, how about 3 and 5 for this statements and justifications? What kind of angles are 3 and 5? That's right, they're vertical angles, right? So how do I know that vertical angles are equal? Is it a definition or is it a theorem? I'm going to start with L is parallel to M, and that's what I'm given. And hopefully you have come up with the fact that it's the vertical angle theorem, right? The definition describes what vertical angles are, but the theorem gives us equality or congruency. So this is the vertical angle theorem. And again, we're going to use shorthand notation. Can shorten our words a little bit. And we are good to go. For tomorrow, I would like you to try to copy number 1. Actually, you don't have to copy it. If you could just hold up this slide on your cell phone or on your computer and look at their multiple choice and choose a solution for 1, 2, 3, and 4. And then we'll start with this page tomorrow. You guys have a great evening, and I will see you then.